I will touch on chapter called non-parametric test. Non-parametric test. Okay, for two-way ANOVA. For two-way ANOVA, so if you look at your Putra Blast, I've already uploaded the slide for two-way ANOVA. So basically, two-way ANOVA content and the slide is similar to your lab manual. So if you browse through your lecture note, which is actually the legacy notes from the Faculty of Science, is basically the same, just similar to your lab manual. So for tomorrow, we will touch a bit on one-way ANOVA first and then two-way for one hour. Okay. So siapa? BCH dulu esok? 8:45. BCH dulu.
BTC dulu.
BTC dulu, BTC dulu. Okeylah, BTC dulu. Orang belanja lah pizza ke apa kat dia orang kan. Give way to you. Okey, tak apalah. BCH nak bangun lewat sikit. Alright. So, for today, sekejap ya. Where were we? Sekejap. Record first.
Recording in progress.
And then share screen. Nak share yang mana? iPad. Okay. Alright, share screen. A while. Okay. Wait. Okay. All right. Okay. So, ANOVA tomorrow. Apa tu? Ada bunyi apa tu? ANOVA tomorrow. Today we touch a bit on non-parametric test. Okay. All right. So just to jog back your memory, so this is should be covered by Dr. Saufi during descriptive statistics. Okay, with regards to the data types, what actually the data types that you encounter in statistics. Okay, the most obvious one is usually we look at the first one, the scale, the scale. So in SPSS, there is an option to change the type of data, maybe nominal, ordinal, or scale at the top column. At the top column is usually reserved for the title, for the title of your variable, your caption. Okay, scale is, of course, continuous measurement. This is mostly associated with the measurement, continuous measurement. Obviously, things that you measure is a quantity. Is a quantity. Can be, let's say, the weight of your chemical, the temperature of the room, and the pH of your solution. That takes a continuous unit. So you have a quantity at the front, let's say your weight, and then attached to the quantity is the unit. Okay. So like what, 5 kg or 5.1 kg. So you can affix a unit at the back of your quantity. So usually it's continuous because you can measure. Let's say for pH, if you start from neutral pH 7, you can go from 7.1 until 7.99, and then you jump to another scale, 8.0 in terms of pH. So there are no disjointed value between the two. Okay, so this one is measurable. Usually is the quantity that you measured. You measure, you weigh, or you take the measurement. Okay, this one clear cut. Okay, there's a scale is also can be defined in discrete. Discrete is in integers or count. Okay. In this case, maybe the quantity is a lot. Like maybe the grain of sand or your let's say the grains of rice, something like that. So you're talking about huge numbers. It's a discrete. You count, but in a huge meaningful numbers. Maybe in a thousands. So it's integer, but quite a lot of numbers. Yes. Small integers or a few of integers can be nominal, nominal or ordinal. So scale is the one that you encountered, and then most tests that is associated with scale is we call parametric test. So for those, so this one is sorry. Okay, so usually we mostly associate scales with parametric test. Okay, usually you look at the nature of your data, which is continuous, and then other rule for parametric test is it follows normal distribution. Normal distribution. How you check the normality is already been touched in test 1. You see your QQ plot. Is it straight line? Is all your what? Your experimental point, is it aligned with the 45-degree line in QQ plot? Is the variance equal? So one is distribution, normal follows normal distribution, and then homogeneity of variance. Homogeneity of variance. Okay. All right. This one is already been touched by Dr. Saufi, so I don't need to touch again. It's just for you, just to jot down, to jot down your memory. Parametric test. The data type is scale, and then follows normal distribution, and then also agree with homogeneity of variance between sample. Okay. Now for today, so there are other data type, which is one is ordinal, or sometimes we call it rank. Okay, ordinal. The word ordinal you can associate with order. Okay, just like there's an obvious order. We put a rank to a value, and then there's an order to that value. Okay, for example, paling senang, the most simplest one I can think of is the level of education. Your education. Okay, maybe you can start with 0 or 1. You put rank 1 for the least educated, and maybe how many rank. Okay, let's go. So maybe first one, play school or preschool. Okay, you can put number 1. And after that, what? Kindergarten. Kindergarten number 2. And after that, what? After kindergarten, primary school number 3. Number 4, secondary school. Number 5, maybe after secondary school, maybe pre-university. Pre-university, like matriculation. Number 6, you put a rank of number 6, undergraduate or first degree. And then number 7, maybe you want to continue to your postgraduate. You take masters. Number 8, maybe PhD. And then number 9, maybe postdoc. Number 10, dah mampus lah time tu kan. Banyak sangat ambil kan degree. Okay, so that's obvious order to your data. That's meaningful order. Okay, nominal, not meaningful. Okay, okay, like cats and dog, black and white. What else? This one, okay, this one you have order. Okay, you have order. Nominal, no meaningful order. And there are data, but in no particular order. You cannot put, but you can put rank, or you can put, let's say, code. Code, let's say dog, you put as 0, cat, you put as 1. Okay, and that's for you, your reference. But dog is doesn't come before cat, something like that. Okay, so that's nominal, no meaningful order. Okay, all right. Okay, now data type, just to reiterate back, nominal, Data do not represent an amount or quantity. So quantity is measurable. So nominal is not measured, but you put rank, or you put some type of ranking in a survey. Example, marital status, single or married, or sex, female, male. No particular order. Ordinal data represent an ordered series of relationship. For example, level of education. Interval continuous, measured on an interval scale having equal unit. But can be sometimes an arbitrary 0 point. For example, temperature scale, you can measure in Fahrenheit, you can measure in Celsius. It's interval continuous. Ratio, variables such as weight, for which we can compare meaningfully one weight versus another. So let's say if another is one person is 100 kg, you can say let's say A 100 kg, so A is twice the weight of maybe B. B is 50 kg. Okay, very simple. Now, all this while you are doing parametric tests. All this while until now, when you do your hypothesis testing, all this while you are being introduced to parametric tests. So most of your data is scale, scale type or interval ratio. Sometimes if there is an interval ratio type of data, it still falls under parametric test. So, for example, F-test. F-test I didn't touch, I think, if I'm not mistaken. F-test is for precision. Okay. You want to test precision between two groups. How precise is the data between two groups? And then t-test is, how different the mean between two groups. So it's slightly different. F-test is actually a component in ANOVA. If you remember, F ratio, one part of it is F-test. And t-test, if you have two samples of data, you want to test the mean. Is it significant between one another? If you have three or more samples to compare the means, so you resort to ANOVA. And later in the next following week, we will touch on correlation and regression. Okay, this is very simple. Okay, assumption of parametric test. Okay. Parametric tests can only be conducted if data are sampled from a normally distributed population. Okay. Another synonym to normal distribution is Gaussian distribution. Okay, so even though your data is continuous or scale, if you have to execute first, conduct first normality test. Okay, please recall Dr. Saufi lecture. If given a set of data, first and foremost, before any hypothesis testing, you first need to test if the normality distribution assumption has been met. Okay. Yeah. Okay. Is if the normality distribution assumption must be met. So by looking at what? By looking at maybe your QQ plot. By looking at the Shapiro-Wilks W test. Okay. If you remember, recall these two things. And also looking at your Z score for skewness and kurtosis. Okay. So this is the three things that you look at. Okay. So if data in each group exhibit similar degree of homoscedasticity, sampai sekarang payah nak sebut benda ni. Always give me tongue tie. Okay. So it's just a simpler way. This is just a fancy way. Homoscedasticity is just a very fancy way of saying that two sample that you test must have similar variance. Okay. If you compare, let's say, you do t-test, you compare between two groups. In order for it to be parametric, both must have similar variance. So you call this homoscedasticity. Wah, dah empat semester aja still lagi tongue tied. Okay. Data are independent. Of course, your data in the sample are independent. So no one data can be a member of two groups. Okay, so you cannot have one data. And let's say data in sample A is also is also a subset of data in B. Okay, so that defies the law of independence. And interval data is data point value should be numerical and measured. Is measurable and give you numeric value. Okay, and that's assumption of parametric. Now, characteristic of parametric test. Let's say you want to estimate parameter, a certain parameter. You want to estimate a parameter of a population, but population is too big. So what you do sampling. So you take some sample from population. So example, you use t-test. So what t-test does? Use the sample mean to estimate the population mean. Okay. So parametric test can maximize the power. Power is 1 minus beta. Okay. Which is the probability of correctly rejecting the null hypothesis. Okay, if you use parametric test, it has more power than non-parametric. It has more power if you compare between the two. But if normality is violated, for instance, maybe your distribution is skewed, what happened to the tail? The tail maybe getting extended or getting larger, something like that. So what happened? If you remember, alpha value or p value is the area under the curve. Let's say if you skew the data, you will change the curve, the curvature. So most probably, type 1 error, which is the alpha, can be enlarged due to the skewness of your distribution. So probability of type 1 error may be larger than the value of alpha selected, and therefore the power of the test, which is 1 minus beta, is not maximized. Okay, because it doesn't have symmetrical in distribution. Maybe it's skew to the right, skew to the left. It will it will give not an accurate estimate. No longer an accurate estimate of your alpha value. Okay, now why non-parametric tests? Just to recall, last few slides, what if you have nominal or ordinal data? Okay, for example, this slide. Now, how can you tell if people truly have preference to one brand or choosing one at a random? Okay, this is a collection of soft drink. You have Sprite, you have Coke, Schweppes, Coca-Cola, you name it. Okay, I stop here. All right. Okay. So that data is the collection of, let's say, soft drink is ordinal or nominal. The collection of soft drink. The picture of soft drink. Is it ordinal or nominal? Aisyah Syari. Ada ke? Nur Aisyah. Always call 3 times. Tak menyahut means you are actually not here. Nur Aisyah Syari. You can use the chat box to answer if you don't have microphone. Ada ke tidak? Nur Aisyah Syari. Okay lah, 3 time maksudnya tak ada lah tu. Today is 1912. 19 December. Kamalin Sofia, how many of you today? 88. 88. Okay. Kamalin Sofia. Kamalin Sofia. Also not around? Maybe also not around. Tak ada Kamalin Sofia tak ada. Okay this class can hold up until 100 100 participants. So as of now we have 88. So maybe 20% of you are not here today or here by spirit. Flora Fujingshi. Flora. Okay, a can, collection of can. Soft drink, nominal or ordinal?
I think it's nominal.
Nominal. Nominal. Okay, nominal. Because Coke is not better than Pepsi, something like that. Okay, thank you. Alright, now let's say sometimes why you want to test, why you want to have a test, hypothesis test. Sometimes let's say for example, all of you, 100 of you, just conclude the test for biostatistics. Okay, just conclude the test. I mean, you sit for test 2, and then you done, and then afterward you want to celebrate or something like that. Okay, celebrate after test or after final exam. So one of you is assigned to buy drinks. Maybe you want to have a picnic at Tasik UPM. One of you want to buy a drink. Assigned to buy a soft drink. So all of you pool money, give to this person, and then this guy go to maybe KK Mart, and then he thinks. So going to the shop, and now he has some thinking. Okay, do I have to buy soft drink randomly? Just take from the shelf or from the freezer, whatever the cans that are in there, or your group actually has a preference. All your classroom, all your batchmate has a preference. Maybe toward Coke, Diet Coke or whatever. So he need to think. Okay, do I need to take? Do I need to buy a random soft drinks? Or I buy a certain brand more than the rest? Okay, so that's the research question that he thinks of. Lepas exam pun ada lagi research question kan? Question. So he need to think. He need to maximize. He need to maximize the money given to you. Given to you to the colleague. Takut nanti waste. Let's say if he buy everything random and then put in a cooler box, and then people came up. So maybe the brand is not to their liking. Maybe dia beli benda lain ke ataupun just let lah. So there's a extra can of soft drink. Okay. So that's one part of it. One part of the example. Simple example. Why you need to do hypothesis testing? Maybe you want to maximize the money. You need to buy only certain can, certain brand, because people maybe prefer Diet Coke. Most of you prefer Diet Coke. But how to prove? Through this statistical testing. Okay. So I would like to share again. Okay, now before I share, now non-parametric test. Non-parametric test, you know that. Sekarang pukul 6. Okay, maybe we only have time to cover non-parametric test. Maybe chi-square we cover next week. Okay. Before we begin, okay, sekarang you dah tahu apa itu nominal and what is ordinal type of data. Right. And then how many distribution are there that you know of? Beside normal distribution, how many distribution that you know of? Fadlullah, is there any more distribution that you know? Fadlullah.
That's okay.
Distribution apa yang you tahu selain daripada normal? Okay.
Positive skewness counted as distribution.
Apa dia?
The positive skewness.
Okay lah, tapi dia tak normal lah.
Not normal.
Dia tak
Normal and not normal.
Skewed. No. Ikut bell shape. Kalau ada bell shape, dia normal. Okay lah, skew. Okay. Skewed distribution, non normal. Okay lah, itu soalan CPCP lah tu. Okay. Boleh lah. Okay. Positive skew, negative skew is not normal. Okay. But dia continuous. Okay. Continuous scale. Okay. Apa lagi? Siapa lagi nak tanya ni? Banyak sangat ni, 100 lebih ni. Iklil wajihah. Wow, such a unique name. Iklil wajihah. Ada masuk Arab ke? Apa maksud iklil? Ada masuk Arab ke? Eh?
Talong.
Apa dia? Apa dia?
Talong.
Kenapa aku dengar tanglung? Betul ke ni?
Talong.
Okay, clear. Okay, so any distribution that you know of? Beside normal distribution? Beside Gaussian distribution? Jangan kata not normal distribution. Tak ada, dia banyak jenis. Okay.
Sure.
Apa dia?
I'm
What
not
else?
sure.
Tak sure. Oh, okay, tak sure. Okay, now I revert to another question. Different type of question. Sebut distribution, korang yang duk Google sekarang lah. Okay, now. Okay, why we call normal distribution? Because most due to the bell shape, due to the what you learned earlier, most things in the world follow normal distribution. Most things, but not 100%. Most scenario, most occurrence follow normal distribution. That's why that's why they have normal distribution. Dia punya nama dia. Although mathematically you call Gaussian distribution, because most occurrence in the world follow normal distribution. Okay, but is there any particular survey or any particular scenario you nak buat survey? Let's say you want to do survey. You want to do, let's say, like what? Like yalah survey lah, survey, or you want to measure. It's not measure like ni lah. You want to do survey lah, senang. Sebelum you buat lagi, you dah tahu dah. It's not normal. Doesn't follow normal distribution. Can you think of anything? Any survey, any type of data, before you did any survey or any particular, stat analysis, you already know that it doesn't follow normal distribution. Ada tak? Boleh fikir tak? Okay. Average height of people follow normal distribution. Class attendance follow normal distribution. Ada tak? Before you even begin, you already know this particular data does not follow normal distribution. Ada tak? Can you think of anything? Ada tak? A type of data, even when you do survey, you dah tahu dah, ni bukan normal ni. Marlene, can you think of anything, Marlene? Because I saw your name there at the bottom. Marlene, agak-agak apa? Data apa? Does not follow normal distribution. Data apa agak-agak?
Sekejap.
Coffee consumption.
Apa dia? Again?
Coffee consumption.
Coffee consumption. How are you going to measure that? Can you elaborate nah? Macam mana? I'm a tea guy. I'm not a coffee guy. I don't go to Starbucks actually. I'm a English tea guy. Okay. Apa maksudnya apa? Frequency of coffee drinker against what? Dia kena tahu kan. You have to elaborate more. Apa dia? Okay.
Not sure, Doctor.
You're not sure. Kan. Against what? Age or whatever kan. Age apa yang suka minum kopi kan. Okay. Nur Amelina Farhan. Okay, ini budak biotek lah. Nur Amelina, where are you? Nur Amelina.
Yes, Doctor.
Agak-agak data apa yang belum buat apa-apa lagi dah tahu. Not normal. This one doesn't follow normal distribution pattern. What type of data?
Not sure lah, Doctor.
Not sure. Susah pukul 6 nak fikir ni kan. How many grey cells are left after World Cup ni? Okay. Dinesh Prasad? Dinesh, is there any Dinesh here? Saja. This is actually my way of taking attendance actually. Dinesh Prasad, going once. Dinesh Prasad going twice. Going 3 times. Okay lah, tak ada lah tu. Okay. Alright, now. Shoe size. Most of you shoes apa? Okay lah, we take UK size lah. Okay, most of you. Shoe size apa? Size apa? Shoe size.
9,5.
Ha?
8.5.
8.5. Okay, lagi? Lagi?
7.
7. Okay.
11.
Okay, tahu tak UK start daripada nombor berapa sampai nombor berapa? Dia punya scale? Dia punya ni? Okay, we take the whole male and female same size je sebenarnya. Kan, same scale je. Okay, minimum berapa? Siapa yang kaki kecil sini? Berapa? Start with what? Start dengan berapa? 3. Pakai apa ni 3 ni kan? Okay, let me share the screen. Contoh, share the screen. Okay, let's see. Okay, 5. Okay, now. Okay, kalau betul-betul follow normal distribution, then the scale, okay, size converge. Okay, ni size dia kan? Okay, UK size start with 2. Yeah, UK size start with 2, end with 11. Now, if you think Malaysian follow normal distribution, sepatutnya most of you berapa dia punya foot size? Sepatutnya. Okay, tengok UK size je lah. Okay, US sama je sebenarnya kan? Okay, tengok UK size. Okay, kalau betul orang Malaysia ni follow normal distribution, most of your feet will be berapa scale dia? What will be the size?
6,7.
6,5. Kan? Ada setengah kan? Okey sepatutnya lah 2, 11, okey 2, 11 and then bukan 7, okey. Now, okey sepatutnya 2, 3, 4, 5, 6, okey lah dekat sini lah 6,5. Median, we take median. Ada ke orang size 6,5? Ada jumpa tak? Ada. Most of you wear 6.5 ke? So most of you fall dekat mana? Which shoe size? Which shoe size? Here. Okay, saya 8. Okay, most of you berapa? Kan? 8. Okay, 6,5. Ada juga orang 6,5. Kan? I don't think 6,5 is the most. It's not the mode here. I think most fall 7, 8, 9. Something like that. Okay. 6. Oh, ada juga orang 6. Okay. Alright. Now, now what happened here is 6, 5 if you are female. If you are male, then it's cute. 7, 8, maybe to 9. Okay. First. Okay. Kat situ saja dah tahu dah. Okay. It's not normally distributed. Okay. Your foot size. Okay. What can you think of? Okay. Ni dah kira introduction lah. Intro. Okay. Anything else that you can think of? Anything else besides foot size? Okay. A more scientific example is particle size in a clean room. Okay. But this one you haven't entered any clean room. I cannot, you cannot imagine what is the number of particle, the size of particle in a clean room. Okay. Okay. Income. Household income. Okay. Does not follow normal distribution. Okay. Why? Okay. Maybe that's why we have, B40, M40, and then what? T dia berapa? T is what? T is T20. Kan? Okay. You have B40, M40, T20. Now, B plus M, 40 plus 40 equals to 80. Right? Okay. Why T20 is special? T20 is 20. So, that's why distribution of wealth follow 80 to 20 rule. Usually, 80-20 rule. You Google what is 80-20 rule. 80-20 maksudnya not normally distributed. Wealth, okay, not so many people are in the bracket, in the wealthy bracket. So many people in the medium household income. Okay, so earning, the power of earning in not just Malaysia but in any country mostly follow 80-20 rule. You call it Pareto 20-20 apa 80-20 rule. Okay. Lagi satu contohlah. Apa lagi Okay, contoh. Okay, the nature of the data. Maybe weather, temperature in a day. If you do distribution, maybe morning sejuk, very very cool in the morning. Afternoon, very high, temperature goes high. Petang mungkin jatuh balik, mungkin pukul 6, pukul 4 mungkin jatuh balik, pukul 6 mungkin naik tinggi balik, something like that. And then malam turun balik, something like that. So it's not normal distribution. Yeah. And another one particular famous example is when you do rating or ranking, or rating lah, very easy rating. Okay, apa yang you suka bagi rating dekat dunia ni? What rating? Makanan.
Online shopping.
Satu. Makanan. Nur Jasmina. Ada tak Nur Jasmina?
Ya, Doktor.
Okay, apa yang follows rating rule kalau bagi survey? Okay, contohnya satu makanan lagi, apa lagi? What else do you can think of?
Test.
No, test is apa? Ni test is usually follow normal distribution. Yes, Louis, hotel. Ni mesti suka berjalan ni, hotel. Okay, cinema, movie, right? Right, your rotten tomato scale, right? Kan? Rotten or fresh, kan? Something like that. There's no in between, right? Okay. Okay, rating. Rating usually what? You put a number, maybe what? 1 to 10. Pernah dapat 5 tak? Ada tak rating dapat 5? Just nice. Maksudnya 5 is like a C or something like that. C+. Kan? Seldom, in a rating, let's say hotel, food or movie, seldom you encounter most data that falls on C, in the middle, whether it's too extreme left or extreme right. Mungkin kalau makanan tu best, hotel tu best. Biasanya hotel kat mana? Hotel ni macam mungkin lah after you spend the night or a weekend at the hotel, and then you go proceed to the tour punya dia punya reservation, the reservation service like Trivago, right? Okay, and then you proceed to put some rating, okay, based on your stay, right? Okay, so maybe from 1 to 10 or 1 to 5, 1 to 5 usually is 1 to 5, because 1 is like so, and then the middle one, 2.5 is like neutral. You cannot give a bad or good impression, neutral, and then 5 is like excellent, service excellent. Usually people put 5 star, something like that. So seldom you see this rating falls on neutral. Neutral. Tak tahu nak bagi dia bagus ke tidak, kan? Seldom you see this type of data. So this particular survey is called Likert scale. Likert, Likert scale. There's a particular name for this survey. This type of survey, Likert scale. Itulah Trivago, kan? Maksudnya some people put 5 for the same hotel. Some people may put 1, walaupun iklan dia bagi tahu apa. Okey, kenapa bayar lebih, kan? Bilik yang sama, kan? Hotel yang sama, kenapa perlu bayar lebih, kan? Trivago punya advertisement, right? Iklan, right? Okey. Bilik sama, 2 harga berbeza. Okey, mungkin satu bilik lagi berhantu, kan? Something like that. Kan? Tu pasal dapat rate murah, kan? In my case, Previously I went to a hotel. Pernah lah juga kena kacaukan hantu. Satu kan. Satu lagi, I went inside. Why I got cheaper room? Because no TV. Right. Tiba-tiba the same room, but the adjacent room got TV. My one don't have TV, right? Patutlah dapat rate murah lagi, something like that kan. Okay. Now, that's Likert scale. Likert, Likert scale. So, yeah. So there are many data that does not follow normal distribution, and some you are encountered in your daily life. You cuma tak perasan sahaja, kan? Okay, sekejap. Oh, if we want to, okay, kena sambung ke sini. Alright. So why non-parametric? Because due to less restrictive assumption, can be used even you have non-normal distribution. Interval or interval ratio data. Use when data is too skewed to have parametric test. Just like your hotel ranking, hotel rating. So many 5 stars and then one star, something like that. Too skewed. There are no, let's say, midpoint, like 2.5 star, tak ada. And then the beauty is parametric, non-parametric, not susceptible to outliers. So if you remember, your normal distribution has a symmetrical bell shape, but due to the arrangement of your data, most of the data lies in the middle that create your mu, your population mu, the average mu. However, if one or two data is so far off from the mu, from the center, so what happened? It creates, enlargement in the variance. Variance akan jadi besar because of these two outliers. Okay. So meaning what? Error, it propagate the error. But for non-parametric, because sometimes you use median instead of mean, and so outliers does not give you any problem. So data usually are given rank instead of using raw score, raw scoring. So we give rank. Okay, disadvantage of non-parametric test, not as powerful as parametric test. When data is normally distributed, so when data is normally distributed, no need to use non-parametric. Go straight away to parametric test. So parametric test more likely to detect genuine effect in the data. Okay, non-parametric, otherwise greater chance of type 2 error. So if you recall what is type 2 error in the previous lecture, type 2 is missed opportunity. There is effect, but they have highly chance that you cannot detect the effect. Okay. So non-parametric has that particular setback of missed opportunity. Yeah. So disadvantages, non-parametric test only for significant difference, no confidence interval, and difficult to apply to complex data. Okay, now, this is the favorite question type in the final. Okay, I bagi tahu you siap-siap. Actually, I'm not the one who formulate the final exam. Usually, it comes from the Faculty of Science, but based on historical data, historical pattern. This one is the favorite to be asked in the final exam. How? Okay, you are given a sentence, a statement, and then the question will ask you, what type of hypothesis test that apply to this sort of statement? Kan? Yeah, given a paragraph, a sentence, and then you need to choose. Okay, what type of test suitable for this statement? Okay, so mungkin so first need to ascertain this data is parametric or non-parametric. Is it normally distributed or not normally distributed? And then see the type of data. Is it nominal type ke, ordinal type ke, continuous ke, kan? Okay, so this is the first section in final usually being asked. So you here you have a counterpart. You have a counterpart of parametric test has its counterpart in non-parametric test. Okay, so independent t-test, you have the counterpart, which is called Mann-Whitney U-test. So let's say you have T, T. In this case, for non-parametric, you have U instead. U, the value of U. In a t-test, you have a value of T, T critical. But this one, U critical, or U statistic, or U critical. Yeah, independent t-test, you have Mann-Whitney. Dependent, or we call this sample t-test, you have Wilcoxon. Okay, Wilcoxon. One sample t-test, you have, let's say, a sample that you compare against known value. Also, you use Wilcoxon. One-way ANOVA, you have counterpart called Kruskal-Wallis test. Kruskal-Wallis test. And this is RAMNOVA, repeated measure ANOVA, RAMNOVA. Macam nama orang Rusia aja, RAMNOVA. Something like that. Okay, so this one, you have the counterpart called Friedman test. Okay. So in final, please read the question several times to know first the type of data. Is it normal distributed or not normal distributed? Sometimes is explained there. This data follow a non-normal distributed, non-normal distribution. Okay, and then you should know, oh, this one is non-parametric. And then what is the type of data? Is it nominal, ordinal? Okay, yeah. So this is the first part in final usually been asked. Okay, you need to match the type of hypothesis test with the statement, problem statement. Okay, now one sample t-test. Okay, so let's say the counterpart, if you have continuous type of, ooh, what happened? Ooh, sensitive. Oh, sorry. Oh, what happened? Okay, sekejap ya. Okay, I need stop sharing first. Okay. Kenapa dengan saya punya, sekejap ya. Dia boleh jam sekejap. Okay. So share again. Ya, sekejap ya. So we have half an hour more. Okay, maybe for chi-square we continue next week. Okay, sekejap. Alright, okay. Okay, so one sample t-test. Okay, if you have a continuous type of data, straight away it's called one sample t-test. But for ordinal, instead of mean, you have one sample median. Median t-test. And for nominal, if you have two categories, you call this binomial test. More than two categories, you have a chi-square goodness of fit. Okay, so this one is the normal arrangement, and this is like if you have a statement, you identify the data type and then the nature of the statement, and then you can use this table to, let's say, match which test that is possible. So different between two independent, of course, two independence, continuous, independent t-test. Okay, but ordinal, straight away is Mann-Whitney U-test. Okay, nominal type of data. Sometimes you can use this with nominal also, not particularly restricted to ordinal, because it's like two groups, two samples. Maybe that two sample has no particular order, so you can use actually a nominal. Yeah. differences between two related group are different. Let's say paired means what? The sample comes from the same subject, the same specimen. Okay. So if it's continuous, you go for paired sample, paired sample t-test. Ordinal is Wilcoxon. This one, McNamara, we didn't touch much. This one. Okay, this one, just look at the question, just identify what type of data and also the is it normally or not normally distributed. Okay. Between differences between 3 or more independent group, of course, 3 or more, you go for ANOVA for continuous. Okay. Now, if let's say you also have continuous type data, but does not follow normal distribution, but even do continuous, go straight away to Kruskal-Wallis. Okay. So even if your data is measurable, quantifiable, but does not follow normal distribution, go for Kruskal-Wallis test. Okay. Yeah. And then there's a nominal part. A nominal, you have a special mention in non-parametric testing. For nominal type of data, for 3 or more, 3 plus group, later you will learn this chi-square contingency table. This one quite special. Quite special. We have one specific lecture for this. Okay, differences between 3 or more related group, which is repeated measurement ANOVA or RAMNOVA. So you have fragment test as the non-parametric counterpart. And then, okay, relationship between 2 or more variables. Okay, relationship usually is correlation. Correlation you will learn maybe in week 12. Correlation and regression is just you want to know whether y is equal to kx, something like that. Okay, regression means relationship. How y relate to x, and then this is the coefficient, correlation coefficient. Okay, this one is straightforward. But for non-parametric type of data, you have special correlation called Spearman, Spearman's or Kendall. Okay, nominal type of data, you also have contingency tables or chi-square. Okay, predicting outcome is usually you have one predictor and many criterion. Meaning what? Instead of y equals to mx or kx, you have y equals to maybe beta x1, beta 2 x2, beta 3 x3. So meaning the changes in y is a function of changes in sorry. The changes in y is actually a function of changes in factor x1, factor x2, factor x3. So mean you try to predict what changes y by manipulating the x value. X1, x2, x3, and so on and so forth. So there are many x. Okay. So for single x1, you call this simple regression, meaning singular x1. If you have more than more than one x, then you call this multiple regression. Okay, multiple regression. So this one falls under multiple regression. This one is only y equals to beta x. That's all. One y and one x. Okay, very simple. Okay, so Mann-Whitney test is the t-test, equivalent, the independent t-test equivalent. So how we conduct Mann-Whitney? We give rank to all scores from lowest to highest. The smallest value we put ranking number 1. Okay, so statistic for hypothesis test is that two distribution are equal is if the sum of rank the statistic for testing hypothesis is that the two distribution are equal if it's follow the sum of rank for each of the two groups. Same, if you rank, you sum all the rank of these two group, you get equal numbers. Then is the null H will be retained. Mean what? No differences between two group. So group with the lowest mean rank is the group with the greatest number of lower scores in it, or vice versa. Okay, just look at the example to understand. So let's say you have two groups, two group sample with 8 specimen, and you give, let's say, a ranking. So this number is a ranking, not measurement but ranking. Okay, you might ask, ini nombor apa ni? What numbers is this? Actually, because I say this is ranking. Okay, not measured. But you put a rank. Okay, two group A and B. Okay, contohlah, maybe I can think of, let's say, this is pain scale. Oh, sensitifnya petang ni. Okay, so this is pain scale. Pain scale. Pain scale. Okay, maybe 67. So 48 lowest pain. Let's say if you hurt, let's say in sport, and then the doctor will, maybe do a survey on you and then put a number on the pain scale. There's a chart. Okay, contoh lah, let's say apa okay, in the maybe not football match lah. Football match so many diva, right? So many people pretending macam Neymar tu kalau kena tackle je separuh padang dia bergolek kan. Tu tak betul tu. Contohnya rugby. Okay, so rugby, let's say there's always a body contact, people hurting people in rugby. Contoh lah, let's say these are players, team A and team B. Okay, a team, two team. And then let's say if they hurts, let's say during skirmish, during scrum or during whatever body contact in rugby. Okay, let's say they will give, let's say this one is 8 person in a team. Okay, so person number 1, let's say opponent dia Serdang Angel, katalah. Okay, doesn't hurt that much. So he give 48 in term of pain scale. Okay, berlanggar pun tak rasa sakit, maybe 48. But team B has a higher threshold, 67. Okay, okay, maybe for person A, 67. Okay, so for 115 or 104, maybe what the pain is higher. The pain is higher. 67 not so much, doesn't hurt, but 115 it hurts so much. Macam mungkin kalau kena langgar dengan Tongan player ke, New Zealand All Black ke, something like that kan. 2 hari koma dalam hospital, mungkin pain scale is 115. Okay, 67, 48 not so much. So what you can do is you rank all from smallest to largest. Okay, so you have a team A ranking system for A, and then team B ranking system for B, and then you arrange from smallest to largest. So 48, you give 1, a symbol of 1, rank number 1, followed by 54, 2, and then team A 67, and the least one is number 3, until so on and so forth. And then what you do is you sum for both parties or both team, you sum them. You sum them, and then you will see, compare between the two. Okay, is it any difference or not in terms of ranking? Difference mean what? There are two. The pain scale is quite different. How you hurt, how you feel very hurt between A and B is different. Is significantly different. If let's say the sum of ranking has different value. Okay, so Wilcoxon sign rank test is non-parametric equivalent to paired t-test. Okay, paired t-test. Okay. So similarly, data are ranked and difference between rank are examined. Okay. Now, Wilcoxon statistic is the sum of rank of positive and negative sign, whichever is smaller. Okay, because this one is paired. Paired t-test mean same group, people that come from the same group, but different tests, different condition. Convert to z-score to allow exact significant value to be calculated. Okay, for instances, all right. For instances, okay, so paired t-test mean what? Same participant, of course. This has been met, same participant, but testing between difference, between differences. Okay, due to two extreme condition, two different condition, but same participant. So you call this paired t-test. So I can't remember the exact test here why this is north and south. Maybe what? Maybe this is bacteria and you put some magnet or whatever. So which one go north, which one go south, and then you do some ranking. So okay, right now, let's say you do differences. Differences. So this one is you read maybe some bacteria go to the north pole due to magnetic field, some go to the south. Okay, so what is the difference between north and south? Okay, so first the list differences. Okay, this is the same same person or same specimen. Sorry Mira nak masuk. So let's say for the list for the list numbers, let's say 48 and 49, you can see. So north minus south, you get minus 1. You get minus 1. Okay, the list differences. So for the list differences, you give a ranking of 1. Okay, but first you need to give an absolute value. So modulus. So because let's say E here, participant E has a -1, but you want to just to make a rank, so you put a modulus to give a value of 1. Okay. So absolute difference is 1, so it has a ranking of 1. Okay. Now, second list differences, what is the participant here? Participant H. 52 minus 54, difference of north and south is -2. And then what happen is you put a modulus, absolute value of 2. So you give ranking 2. Okay, now the third one is okay. The third one is a tie. A tie between between F. A tie between F and J. Okay. Between F and J, there's a tie. So you cannot give either one, number 3 and number 4. So you must be equal. Yeah, both has a difference of 3. And then absolute difference of 3. So what happened is 3 plus 4 divided by 2, 3.5. So both share the same rank of 3.5. So meaning 3 and 4, they are no longer number 4. Both occupy 3.5. Okay. So because they are 4 is vacated, there are no people, no specimen occupy number 4. So the next logical sequence will be number 5, which is D. Number 5. So that's why you have 5 here. And then number 6. Number 6, a tie between B and L. Okay, 6 and 7 is a tie because both has difference of 5, absolute difference. So again, 6 plus 7 divided by 2, so both has 6.5. 6.5 as the ranking. And then 6, 7, okay, 8, 7, 8 and 6, 5, 6 and 7 is occupied. And then you start with 8, but there's no 8 because why? Sorry, 8, 9, and 10. There are 3. Here there are 3 sample that has the same differences of 6, 6, 6. So 8, 9, 10 ranking is being shared, split between the three. So that's why 6, 6, 8 plus 9 plus 10, and then you divide by 3, you will get 9. Okay, so on and so forth. So that's how you do ranking, Wilcoxon ranking. Yeah. So if ties, absolute difference are the same, give each different an average of the rank that they occupy. Okay, for example, absolute difference of 6 occurs 3 times, which is the point that you should put ranking number 8, number 9, number 10. 3 specimens shared the same rank, so you divide by 3, you assign 9 for them, for each of them. Yeah. So for the difference that have positive difference, if you go back one slide, positive difference. Where is the positive? So many, right? So many different of positive. You have maybe you have 11. You have 11. You have 6.5. The one that discounting any negative. So you look back. You have 11, 6.5, 9, 5, 3.5, 9. By looking here, maybe I just put. You have apa ni? 11. Kenapa pula ni? Sorry. You have 11. You have 9. Sorry. 6, 11, 6.5. Berapa banyak tadi 11, 6.5, 9, 5, 3.5, 9. Okay. The one that has positive difference. Positive difference 11. Okay, 11. Okay, 6.5 positive, 5 positive, 3.5 positive, this one positive. So this one positive, this one positive, this one positive, this one positive, this one negative. Okay, this one positive. Okay, so 11, 6.5, 5, 3.5. There's a 9 somewhere. Okay, this one is 9. Okay, all right. So, and then add together the rank of the negative differences. So you have 2, 1, 2, 9, 3.5, 6.5. Okay, So the R plus of positive differences, you add up, you get 44. But for negative rank, you add up, you get 22. So this is actually a differences. So if no differences, the sum of the rank for positive and negative difference will be the same. If no differences. But in this case, there is a difference. This is a difference. The sum of the rank for one will be smaller than the others. In this case, R negative is 22, smaller than 44. So you can say that there is differences in the scale. There is differences in the scale between A and B. If you go back again, there is differences. Maybe in the treatment or in the pain scale or whatever between group A and group B. Something like that. Sorry. In this, sorry. Okay, in this particular example because this one is paired, not the other one. Terlepas ke belakang, sorry. So in Wilcoxon, because you are measuring the same participant, 2 condition or 2 different treatment, meaning what? This treatment give effect to the same participant. Okay, sorry, not the first one, not the earlier slide. Okay, right? Because due to the numbers different in 44 and 22. Okay, so finally, Kruskal-Wallis is non-parametric equivalent to one-way ANOVA if you if you encountered with the data, you face, if you reading a data and then you proceed to do normality test first, and if the outcome says that data is not normally distributed straight away, instead of normal ANOVA, go for Kruskal-Wallis. So group to compare, at least you have minimum of three, three or more. One independent variable and different subject are used in all various group. Meaning what is different participant in all these three different sample, different participant, different individuals. All right. For example, does height of plant differ by location? So dependent variable, the one that you can measure, is actually the height of the plant. Maybe what in meter or something like that, in cm or in meters, something like that. Independent variable, is the location. So in this case, is this ordinal or nominal? Most probably maybe is ordinal. Ordinal due to the elevation in the land. So slope, valley, hilltop. So in cm, the height given here is descriptive table. The height of plant planted in the slope area. There are 7 of them. Mean rank is 5.64. Hilltop 9.75. Valley 16. This one is maybe ordinal type. Ordinal type. Even though this one is continuous. Even though your measurement is continuous, but this one is ordinal. So the mean rank, shows that plant located in the valley were on average taller than those located at the hilltop or the slope. Okay. All right. So surely this does not follow normal distribution. So this does not follow normal distribution. Okay. So you use chi-square. So the significance value, the significant value in, let's say, the elevation is significant. Is significant. So you can conclude that this one is in your lab. So this one is one of the exercise in your lab. In your lab manual, you can encounter this. So test statistic, you will do a chi-square on the height of plant. You are getting a 0.004 significant, which is less than 0.05. So you can conclude that the location of plant affect the height. But you do not know where the difference lies. Okay, in this case, just look, just do a comparison, a pairwise comparison. But for non-normal distributed sample, instead of t-test between pairwise group, pairwise pair, you use also Mann-Whitney. So in Kruskal-Wallis, independent, non-normal distributed pairwise test, we use Mann-Whitney test. Maybe to compare between slope and hilltop, valley and hilltop, something like that. Okay, use Bonferroni correction. Use Bonferroni correction, which is what? To lessen the type 1 error. Because Bonferroni, if you have three sample, so your type 1 error 0.05 will be divided by 3. This one is to minimize the type 1 error. Okay, so this one is the result of pairwise comparison. So you do a Mann-Whitney, you test, Mann-Whitney you test, and see at the two-tail significance. So slope, this one is what? Slope versus valley. So for the plant that is planted at slope, if you compare against plant that is planted in the valley area, you have significant difference because P is 0.004. If you compare hilltops and valley, not so much differences. So from here, you can always, you can already do subset. Okay. And slope versus hilltop, not so much different. So In this case, alpha is by using the Bonferroni requirement, you divide by 3 to get alpha at 0.016. Okay, so in this case, 0.016, hilltop versus valley. Hilltop versus valley, this one may be significant. Okay, because alpha is 0.016. Okay, so you have a conclusion that say that height of plant located in the valley, because valley versus slope, and then valley versus hilltop. Okay, alpha 0.014 is less than 0.0167. So the one that is planted in the valley is much more different than the one in the slope and also the hilltop. So because here is 0.004 and here is 0.014, which is less than 0.0167. Okay, so you can see that those are planted in the valley, very different in terms of height. Okay, but no significant difference between slope and hilltop. Okay, so this one, I think this one is from the manual, from the lab manual. Maybe tomorrow, if I'm not mistaken, maybe tomorrow. Tomorrow or next week, we can have a look at this. All right, for chi-square test of independent, this one is another separate lecture. This one we will continue next week. Okay, so 5 minutes lagi nak habis. So I end here. Okay, this one very simple. This card. This one is very simple. Okay, usually less than one hour finish chi-square. But okay, we left that for another week. All right, so that's about it for today. Tomorrow we will do on one-way ANOVA and two-way ANOVA SPSS test, SPSS lab. All right, okay, so I stop for today.
Recording stopped.
Okay, don't forget to key in your attendance, in Putra Blast, don't forget to do that. Takut nanti kan apa less than 80% pula kan. Okay, the one that Dr. Sophie already did for you, the attendance access. Okay, thank you everybody. See you tomorrow.
Thank you, Doctor.
Thank
So
you, Doctor.
esok BTC dulu ya. Esok
Um,
BTC
Thank
dulu
you,
ya.
Doctor.
Okay. Format untuk test tu biasanya subjektif biasanya. Ke format macam mana you nak tahu ni? Macam tu lah. Dia tak ada objektif biasanya. Rasanya subjektif. Question will come from Dr. Azwadi. Okay. Question will come. Okay. But hopefully maybe sampai T-test je lah. I rasa sampai T-test lah. Tak sampai ANOVA kan. ANOVA biasanya maybe final. Okay, something like that. Alright. Okay. Thank you. Okay.
Thank you, Doctor. Thank you, Doctor.